A function is anything that gets input and produces an output. But in mathematics, there are some changes. Let me say it again. A function is anything that gets input and produces a unique output from that input. So, which leads us to the definition of the function in mathematics, which states a function is a relationship between two sets, the inputs, which is also known as domain, and the set of outputs, which is also referred as codomain or range. So it means that whenever you input into a function, the output we get from that input must be unique. What is the opposite of it? Whenever I give an input into a function, it gives me two outputs from that one input. Okay, so let's get straight. Anything we input into a function, it gives me unique output. Let's understand this by the concept of mapping. This is the first set A, which is containing the inputs, so on. And here is another set B, which contains the outputs. So the concept is whenever I input A, it gives me the unique output, which is B1. Whenever I input A2, it gives me B2. Similarly, A3, it gives me B3. So there is a unique output according to each input. So let's discuss the opposite of what I said. Whenever I input A1, it gives me B1, fine. But also it gives me B2. Okay, so that is the violation of the property of a function. The definition is whenever I input A1, it should give me the unique output, only one output, but it is giving me two outputs. So that is not a function. Now let's talk about the representation of a function. The function can be represented in three ways. Okay. First is algebraically. Second is graphically. The third is in table form. Okay, in algebraically, we write functions in the form of equations like f of x is equal to anything. For example, I write x square plus 1. So this is a function. By the way, this is the notation of a function where f represent the function and here x, this is the input every time we give to a function. For example, if I write 2 here, then 2 will be replaced here 2, 1, 2 raised to the power 2 is 4, 4 plus 1 equals 5. So this is the way of writing functions algebraically. By the way, you can also write g of x, h of x, or anything. That doesn't matter. So in graphs, there are some functions that understood what their graphs look like. For example, let me write a function f of x is equal to x square. For example, this is a function. Okay, so its graph looks like this. Okay, for example, if f of x is equal to x, then its graph will be a straight line like this. For example, if f of x equals mod, then its function will look like this. There are many functions which have their graphical representation, and in table form it's very easy. For example, let me write two columns. Let's say x is the input column. So whenever I input 1, I get 5. I input 2, I get 7, 10, 100, for example. This is just an example. So the point is here to make you understand there are three ways to represent a function: algebraically, graphically, and in table form. Okay, so let's understand the operations of functions. First of all, there are 6 operations: add, multiply, division, and subtraction. These four we are already familiar with. These are the arithmetic operations. I assume that you already understand this. It is very basic and easy. So the other two called the composition, and the last one is inversion. Composition is to combine two functions. For example, if I have f of x is equal to x plus 1 and another function named g of x equals x, say x plus 3. Okay, so to combine these two functions, we perform an operation called composition. We put g of x, this whole function, in the place of another function's input here. Usually we input numbers as input in every function, but in the case of composition, generally speaking, I can write a function in the place of another function, in the place of input of another function. For example, f of x is equal to x plus 1, right? This is the first function. So in the place of x, I may write g of x. Okay, on the right hand side, I put the actual value of g of x, which is x plus 3. So x plus 3 on the place of this, and 1 will be written as like. So after simplifying it, it will become x plus 4. So here I performed an operation called composition. I hope you got my point, what the composition is. So inversion is an operation which undoes the effect of a function. A function f of x is equal to x plus 4, it is a function. So what does inversion do? So what is the mean of an inversion? The process of creating the inverse of a function may be a bit lengthy here. Not that lengthy, but for the sake of the video, I just write symbolically like f of inverse x is equal to, here will be the inverse of the function. So the point of this video is to understand what a function is. So to wrap up, first I talked about the function generally, not in mathematics or computer science. I just talked about what a function is, which is a function is anything that gets input and produces an output. Then I talk about the function in mathematics, which leads us to the definition of a function in mathematics, which is a function is a relationship between two sets, domain and range. Every input produces a unique output. Then we talk about the representation of functions and the operations. And among these topics, I introduce you the notation of a function, which can be f of x, g of x, or anything you can write on the place of f or g. I hope you like this lecture. Help me improve by sharing this video. Write down the comments on the comment box below and also subscribe the channel. Thank you very much.